it's my pleasure to be here. I'm just going to be here for one very quick slide, and also to introduce Francesco, who will talk about in more detail about the platform that eCord provides on ONOS. So I'm here just to introduce you to the general eCord idea and its value proposition. Our idea with eCord is to build upon the basic core platform, which are the open source software, the commodity servers, and the whole ideas that were presented today in the core basics track. Leverage the threadless fabric that was presented by Charles, almost as a control plane and orchestrators with XOS. But obviously eCord, as one of the flavors of Cord, wants to add some elements. In specific, we want to add 3 elements: virtual network as a service, integrated analytics, and custom services for enterprises. So what we call virtual network as a service provides a self-serve portal with zero-touch provisioning, with simple on-premise equipment, and it brings together broadband and SLA connection. And Francesco will show you how to set up this virtual network later. Then we add integrated analytics to observe, control, and adapt the network through programmable probes, and also on-demand monitoring through OAM and CFM. And as a third element, we add some key features that are strictly needed by enterprises, which are security, application policy control, wide area network acceleration, etc. But the whole point that I want to make here is that this is built on the open flat platform, which is Cord, and it brings together the data center economy and cloud agility without having to change the base. It just adds layers on top of it, new services, new equipment, but the whole point is that if you have a Cord pod which you built for our Cord, you just simply change the deployment process a little bit, change the profiles, and you deploy eCord. Obviously, you need a proper CPE, as Francesco will tell you later. So it's my pleasure to introduce you Francesco. He's from Polytechnic of Turin, and he did his work with us at ON.Lab, and he worked on the integration for ONOS of the eCord platform, and he will go in detail about it now. Thanks a lot.
Thank you, Andrea. So, as we all know, operators want to exploit their resources in the most dynamic way, virtual network on demand, bandwidth on demand, and they want to do this having a unified view of their resources, access and transport. Then we all know that the physical network is very heterogeneous. We have many different technologies, and so if we want to have an end-to-end control over a wide area network, we need the notion of topology at the global level, but we do not want to operate on a per-device basis. So here we decided to decouple the controllers in a hierarchical fashion, and we have to have a domain-agnostic global controller and multiple domain-specific controllers at the edge and the transport networks. Last but not least, with the hierarchical approach, we can address the scalability issues, which in a wide area network is to be taken into account. So this is the very high-level architecture of eCord. We have a WAN orchestrator with a service portal for the customers' request, XOS for the service graph management, and the global ONOS, which takes care of controlling an abstract view of the underlying topologies. And then we have multiple edge sites, specifically core sites, and possibly even the transport network under the control of the platform. This is not mandatory in the sense that there is also the scenario in which we overlay the transport network, because transport network can be MPLS, optical, can be many things, and we can only act at the edges. But let's keep it into account also So I focus on this whole platform. Okay, as an example, the user request for a layer 2 VPN, the orchestrator will take care of provision this service, split the request into multiple configuration policies, and push down the rules to the local domains. Okay. Of this whole architecture, I took care of the networking part, control plane, so the hierarchical ONOS control systems. And we have two main functions of the global domain and music controller. Two main, there are many more, much more, but let's focus on these two. So first, at state 0, the global ONOS will receive an aggregated view of the underlying topologies. Once the global ONOS will have this virtual topology, let's say, it can start to satisfy custom user requests from top down, so with call chains of top down from the global to the locals. So the topology abstraction, this is a more detailed, even if still high level view of the software components. If you want more details, you can find the code on the open code repository, or you can ask me later. So the topology abstractions is a bottom-up chain calls. So we have a big switch service that listens for activation of devices, physical devices. Through an HTTP channel, it communicates a virtual vSwitch. We use this notion of virtual vSwitch with only the relevant ports for the service to be satisfied. So in this case, we have implemented carrier Ethernet service, and so we need the user-to-network interface where customers attach their local networks and the network-to-network interfaces. In the global ONOS, there is a virtual provider that notifies these virtual items, and then we are ready to satisfy customer requests in the specific Ethernet virtual circuits request. So from top-down calls, chain calls, we have EVC request, an EVC request that comes from the global orchestrator. The carrier Ethernet application in the northbound interface takes care of applying an admission control, splits the EVC into multiple forwarding constructs for as many edge domains that are involved. So also it applies the routing on the virtual topology, and then generates the service tag, which is a QNQ VLAN tag for the service provider networks. Then through the HTTP channel, as in the role of the client, sends the forwarding construct to each of the local domains. In this case, it is the access topology, so the edge of the central office. And there is an application that translates the forwarding constructs targeting a virtual vSwitch into multiple flow rules for the local, for the actual physical devices. So the CPEs and the Ethernet edge for the access topology. The virtual Ethernet edge also applies an admission control at the local level and set up the quality of service profile defined in the Ethernet virtual circuits request. The same process at the global level applies for the fabric, the central office fabric. So we have the same components with which HTTP channel to receive the forwarding constructs, but then a different application to configure the segment routing application that controls the fabric of the central office. So the interface, the implemented interface here is the same as here, but then the implementation is different because here you want to cross-connect the fabric for the connectivity, end-to-end connectivity, while here you want to set up tagging and quality of service queues. And if we control also the transport network, as in this case of an optical transport domain, we deploy the same components into the transport controller, and then we have an application that applies admission control, and in this case of optical domain, if it is needed, it can apply an algorithm of routing a wavelength assignment to set up light paths. So in this case, with this mechanism, we have end-to-end control over the wide area networks. Okay, and this is a very simple slide where you can see the packets. So from the branch office of a customer, the Ethernet packet enters, then there is the QNQ tag. The Ethernet address simply forward packets to the fabric and apply policy, and then the fabric forwards to the transport network. And this is the Ethernet virtual circuits setup. Another key aspect of the communication between global ONOS and local ONOS, let's say, is the intercluster communication. We know that ONOS is a high availability system, so we can have multiple instances of a single cluster. In this case, of a single instance for each cluster, we have a one-to-one relation. So many underlying domains communicate with a single instance of the global. In the case where we exploit the multiple instances of a cluster, we have an end-to-end relation. So thanks to the leadership service of ONOS, we can load balance the communication between the global and the local sites. There is still one thing to consider: how to handle the remote endpoint. Let's stay here in the global. If we want to contact this local domain, which endpoints should we use? There are two cases, two scenarios. We can either configure the global ONOS with a single fixed endpoint per cluster, and then in this case we need an external component for the load balancing and to recover upon failures of one of these instances, because you use, for example, a public IP given in configuration to the global. Or you can give, in configuration to the global, a list of cluster endpoints. So you can implement the logic of load balancing and high availability within the HTTP channel that we developed. This has an increased complexity, but gives you the opportunity to do all in ONOS. And this was another key point of the hierarchical system of communication. Current activity, the core fabric integration, so this piece is still a work in progress and should be ready in the next couple of weeks, so that we have finished the access part of the WAN. Then we are building this one for the core fabric, and also a use case for the transport network will be based on the optical domain. Another work in progress is the layer 2 monitoring, delay and delay jitter, end-to-end delay and delay jitter through OAM standards, which are available in ONOS. And then we are designing the global orchestrator for generalized service provisioning, not only carrier Ethernet. So in order to spawn BNF from the global orchestrator down all the way down to the core sites. Planned activity, we are also thinking how to integrate ON.Lab as a global orchestrator of record, and how to design BNF running on CPEs when you have x86 architecture as CPEs. And then ultimately we want SD1 services provisioning through all open source software. So dedicated access lines for enterprise customer, which is the carrier Ethernet service. On demand, not only layer 2 but also layer 3 VPN, and then on demand virtual network function provisioning in a wide area network. Challenge is scalability. Scalability is both a motivation to this work, to the hierarchical approach, but it's also a challenge because for example, with 5,000 central office to manage, you have, let's say, 10,000 users per central office, you end up with 50 millions, at least 50 millions user to network interface to manage, to control in the global orchestrator. Because the topology aggregation, the big switch, of course. And also you have multiple EVC per user to network interface. And then we need a bottom-up control mechanism to address failures, especially in the inter-domain links, because these links are not fully under the control of a single ONOS controller. And that's it. These are the pointers. Open code under Carrier Ethernet application, you can find the code. It's not very complex. You can, if you have questions, write me anytime, and if you have questions right now, just ask me. Maybe a little bit too fast. Okay. I was very fast, okay. Because I didn't enter into details on how this HTTP channel is actually developed, because maybe you can find it boring, but there is both client and server endpoints here, because it's a peer-to-peer communication based on HTTP REST, so clients and server in both directions, and this handles multiple calls to the underlying domain, so it's a multi-threading component. And while for the server sides of both global and local ONOS, I exploit the Jetty HTTP servers that comes with the OSGI system of ONOS. The big switch service, which is the other common component to each pieces of the local domains, is a component that listens for the device activation and then communicate them to the HTTP channel. So HTTP and big switch service are all common components in all the local domains. While what changes between domains is the application that receives the calls from the global ONOS, because you have to translate into technology-specific flow rules, device-specific flow rules. So here we are operating on a per-device basis. Here we are operating on a per-domain basis. But we need the notion of topology, right, to understand which edge sites are involved into a request. And this is not only about carrier Ethernet, this is all about all the network on demand. In this way, we address the scalability issues, aggregating the devices, but as I mentioned before, if you, with thousands of customers connecting to the central office, you will have millions of user-to-network interfaces, and we still need to do testing on this stuff, because we just released the first version of the whole platform. You can try it. It's easily installable on JVM, both the global and the local, and you can build your own application for your local domains. Of course, our interests are the access links, the central office, and then a use case optical domain is under study here, to apply an admission control for the light, for the EVC setup on a light path, no installed light path. So, okay, I finished a little bit earlier, but if you have questions about the implementation here.
Yeah, for the global site,
Yes.
do you need any core fabric or core service in the global site?
Core service.
Core fabric. No, you don't need a core fabric.
No, exactly. You don't need.
Yeah, you only need a ONOS controller.
Why?
No. I said that you probably don't need a core fabric in the global site, right?
Exactly.
Okay, and you just said that it's a domain controller independent. But it seems to me that your global controller need to talk to the domain controller. And,
Yes, but there is a common API here implemented in each of these applications, which is a common interface, which is the forwarding construct installation, if you want. So this process, these APIs are all the same for all the underlying domain. This calls is all the same.
yeah,
Okay.
but in this case, you assume that the other domain also use ONOS and use segment routing, kind of.
Let me help a little bit on that. So it's not completely aligned as of today, but the API used for the communication between the global and the local is based on the MEF for the construct API. So technically, as long as the domain controller speaks that same API, it should be swappable.
Okay.
But it's not like we've tested other
Okay.
things, but in theory, it should be swappable.
Okay.
Thank you.
And another question is that, to me, probably the global controller should not try to communicate with the ONOS access, because ONOS access and ONOS fabric belong to one single domain. It's a central office.
Ah, okay. You mean this is a single domain?
Yes.
Okay. Yes, this is actually they belong to the same domains. So in the topology view here, the device is the big switch exposed by the fabric and the access. They have both the same domain IDs. But since the code setup is based with two ONOS, I decided to expose two different devices because it was more compatible with the current core setup.
Yeah, so I'm thinking the application scenario is the equal for a huge service provider, or it is designed for two separate service providers to talk to each other.
This is for the
Single
because the hierarchical who has the authorization
Yeah.
here.
Yeah.
Only one system. You need an east-west interface to communicate between service providers. But there it comes the issues there are the more, let's say, politics, policy issues, not technology. Not technology issues.
Yeah, I know.
SPGP, no. So yes, this is designed for a single provider to provision enterprise level connectivity, dedicated lines to enterprises. This is the first use case, career written application. Then we want to, you can use this abstraction also for other connectivity types.
Yeah.
Okay?
Thank you.
Thank you for your questions. I thought it would have taken 30 minutes instead. This morning I tried it was. Okay, there is the code on the repository, I already said that. Okay, in the current release is based on this option, single endpoint per cluster. And that's it.